which is showcasing their product, is Blaize Inc. Blaize offers transformative computing solutions for AI data collection and processing at the edge of network with focus on smart vision applications, including automobility, retail, security, and industrial. We have with us Mr. Tapan Kumar Joshi, Director of Product Engineering at Blaize. Mr. Joshi is a Director of Engineering at Blaize and leads Blaize Client Engineering Group. He has been building, driving, and delivering engineering teams in areas of AI systems, software, algorithms, embedded systems, DSP, and mobile communications. So now I would request Mr. Tapan to share a few AI edge computing use cases. Mr. Tapan, thank you for giving us your time today. Now the stage is all yours.
Thanks a lot, Sridevi, for the introduction. Hello, everyone. Good afternoon, good evening, based on the time zones you are in. Let me just bring up the presentation. Fantastic. So my name is Tapan Kumar Joshi, as Sridevi introduced. I work with a company called Blaize, and Blaize is one of the leading AI edge computing product development company. We make platforms and systems which enables our customers to make their AI-based edge products, right? So let me quickly walk you through the quick introduction of our products. We make accelerator-based platforms as well as embedded platforms. And the heart of our products is our core IP called glass streaming processor. So this is the processor that we researched for a couple of years, architected and designed, and it is definitely reaping the benefits of all the hard work that we have done. This is a 16-core system producing a performance of 16 TOPS with a typical power consumption of on an average 7 watts. The another salient benefit of our product is it is 100% programmable, right? So this enables AI developers to do, say, for example, you can develop your own custom model. You can build your own custom kernels, right? Or custom layers and plug into your CNN or DNN models, right? So that's a benefit of this architecture. We also incorporated very efficient memory design, right? And certain optimization. And this enabled us to get a better memory utilization, right? Having less of a memory bandwidth traffic on the memory bus, having the lower latency, and as a result, producing higher performance, and definitely the higher utilization of the compute engine, which results into a better efficiency, right, of the compute. So these are the comparisons that you see. These are the comparisons like 50x less memory bandwidth, 10x lower latency. This is our own comparison with general purpose GPUs, and we have derived our benchmark results in terms of multipliers here. So these are our core products. We have segregated that into two batches. One is the software, right? So AI software piece has a traditional coding environment, the traditional SDK having, say, a low-level kernel driver, the compiler, the set of libraries, the vision driver, et cetera, right? Including debuggers and profiler. The another environment is the visual code-free environment called AI Studio. AI Studio is an environment which is very beneficial for data scientists who want to stick to their core job rather than becoming efficient AI coders, right? So without knowing much detail about the programming, data scientists can make their models, can train their models, can deploy their models onto the hardware, and they can do inferencing very efficiently. Going to the hardware products, we have two main batches of products. One is the Pathfinder generation of product, which is embedded. Here we have SOM, which is a system on module product under Pathfinder. This is pretty small. I mean, a very efficient form factor. You can compare this with size of your credit card or debit card, right? It's such a small system on module package. The other is the Explorer. Explorer is our hardware accelerator product line. We have various form factors here. So you can get the half length, half height PCI card form factor. We have EDSFF form factor, which is enterprise and data center small form factor. And we also have the half height, again, half height and half length accelerator card with 4 SoCs on it. So this is to generate high compute for products that need this level of compute. For example, data centers, right? For example, the heavy compute that you need and acceleration that you need in, say, a video aggregator box, right? Which does a lot of, which takes a lot of AI camera feeds and does the security surveillance, right? For example. Okay, now we shall move to demo section. We will show some examples that we have executed with our customers in real world environment. And we have taken small samples out of it, and we would like to share with you here. All right, so the first example is multi-camera object detection. This we ran on our EDSFF card that you can see in the picture. We took 5 independent 1080p, that is HD video quality streams from 5 different cameras. Here for the demo purpose, I'm going to use the stored videos, but in real case, we took 5 video streams from 5 cameras. We fed that to 5 different YOLO 3 networks, right? YOLO 3 models. And we ran the inference in less than 100 milliseconds. So this is another example, which is very typical in medical imaging industry as well as in automotive, right? So here we took a feed of a full HD camera stream and fused it with LiDAR sensor input and did the sensor fusion. So this particular sample, this particular demo, we ran it on our Pathfinder P1600 SOM system on module. This demo does some pre-processing as well. Same was the scenario even for the previous demo that I showed, right? So it uses ISP filters in the pre-processing. Then we are doing the semantic segmentation using a network called SwiftNet. I think many of you would know about it. And we are doing a sensor fusion where we are taking, fusing the feed, the video feed from the camera and the LiDAR point cloud data, right, to do the sensor fusion and create the fused image, fused segmented image. So let me show you the demo.
Audio in your video is not audible to us, Mr. Tapan.
Oh, is it?
Yes. Can you replay it?
Was that the case even with the previous video or?
At least this video I couldn't hear.
Okay, sure.
It's better we play both the videos.
Okay.
While sharing, please enable the audio. Video sharing.
Okay. I'm sorry, I'm playing the previous one again.
Even now, we are not able to hear again.
Okay.
In the bottom left, share audio checkbox is there. That has to be enabled.
Okay.
Alternatively, you can share this video to us. We will play it after our session towards the evening. Shall we move on with the rest of the presentation, if it's okay with you, in the paucity of time?
Sure. I mean, this is really surprising because.
We will surely share this after a few sessions or in between sessions.
Okay. Give me a second. I don't know why you're talking about features that I'm unable to. Okay, sure. Sorry. So shall I proceed with the previous one, the second video? At least I'll be able to narrate it when we play it. Is that okay, Shridevi?
Pardon?
Can I play the second video and
Yes.
I'll do the narration of it?
Yes.
Okay, fantastic. Okay, so what you see here is we are feeding the bare image from the camera, right? And then we are using the ISP to convert that into the RGB stream, right? And post that we are feeding that into the SwiftNet network, which is a semantic segmentation network. You see all the segmented objects here, which are color coded, right? And finally, we are feeding that and clubbing with the fusing with the point cloud data from LiDAR, right? So this is the sensor fusion algorithm running, which is fusing two data and creating this image for vehicle to navigate. Okay, this is the third demo, which shows the multi-network use case on our Explorer, which is accelerator platform. Here we are using two back-to-back networks, right? The first network does the object detection. The second network does the pose estimation. So for detection, we are using YOLO 2 here, and for pose estimation, we are using PoseNet. In the beginning of the pipeline, we are processing the input, camera input through ISP filters that you can see on the screen. And finally, we are doing the key point tracking. So as you know, the pose estimation, right, the PoseNet network that we are running detects uh, the key points on body joints, right? So after that key point extraction happens, we are tracking those key points using a tracker called KLT tracker. So let me play the video and do the narration. So here as well, you would be able to see you'll be able to see the bare input, which is being fed to the ISP filters, the set of ISP filters that you saw on the previous slide, which cleans up the image, which converts into RGB, and that is being fed into the object detection network, which is YOLO 2 here. So here on the screen, what you see is the programmability feature that we spoke about. So this is our VS Code IDE GUI, right? Where developers can code, debug, execute their written code, right? So this example was also, I mean, if there was an audio, we were also trying to show. We are also trying to show the programmability part of it, and by showing the VS Code Studio screen. Right. Here you see a tool name again, which is called NetDeploy. NetDeploy is our the conversion tool, which converts your model into an intermediate representation, does the quantization and pruning. Pruning, if required, a user can set it, and then generates an application out of it. an application which can be compiled and run onto the hardware. So this is a very intelligent tool which supports several machine learning frameworks, just to name a few: the PyTorch, the NetDeploy, Caffe2, Caffe, TensorFlow, etc. Right. Why we are talking about a high accuracy here? Because NetDeploy also hosts our own researched optimization algorithm, quantization and optimization algorithms, which ensures that even with 8-bit integer, we retain the maximum 99% of the accuracy, and we boost the performance. Right. So this is more of, I'm sorry. So here is the screen that you see. The objects are being detected. Their body key points are getting detected. You see the pose estimation here. And the green arrows that you see, yeah, that shows the key point movement. So say your shoulder joint is moving towards some direction. So arrow would be pointed towards that. So this is the functionality of a key point tracker. This is the last two slides. AI Studio, as I told, it's a code-free environment that we have, which helps data scientists to do their core job, right, without having to learn the coding, right? So we also have a conversational assistant in this, where you can talk about what you want, or you can type, right, what you want, and then the tool takes care of giving you the proposals, right? And you make your own choices and go through the entire journey of making your own model, training the model, deploying the model, right, and getting the inference done. So a short presentation on that quickly.
Mr. Joshi, we are falling short of time, and in this presentation again, audio is not audible.
Yeah, sure. So as I said, this is the same flow where we talk about what we want to do, right? We want to build, say, for example, an ISP project, right? There are pick and choose kind of options available. There is something called Blaize Marketplace, which is our own marketplace where you can go choose your filters, build your pipeline, and do the execution. This also provides you the selection of models, data sets, which you can choose and train and deploy on the hardware, which is on the back end. We have our own Blaize hardware running. So it can be run in our environment. It can also be, the environment can be hosted with the user, that is a customer. So Sridevi, in interest of time, I think I'm just rushing through this one. But in summary, that is what this meant. User can also set a couple of optimization parameters, and this is something data scientists can understand, right? Whether you want to do a quick quantization or you want to go through the whole data set and do a detailed quantization in order to achieve the highest possible accuracy, right? So this is the example of deployment. This, if you see on the top, right, it shows you the complete flow. You added the data, you added the model, you optimize the model through the parameters given on the screen, and you deploy on the hardware. This is creating a deployment environment on the backend hardware. So this makes data scientists' life very easy, right? Or even for novice level of AI developers or developers who are not much kind of expert in coding and AI algorithms. I think that this tool certainly makes their life easy. So Sridevi, this was my last slide. Thank you, and sorry for the audio glitch.
I would request you to share your videos to us. We will ensure that they are shared to the audience at large in the next few hours, intermittent, in between sessions. So thank you so much, Mr. Joshi. Thank you, and have a good day. So
Thanks
that's
so
all,
much.
folks.